Good morning, everyone. I'm Tanishka. I'm a comms specialist at RMI, and I'm delighted to be your MC for this convening. The question we're asking today is, can today's air conditioners keep up with a hotter, more humid world? Now, humidity is a familiar friend to all of us here in India. And as temperatures rise every year, we're seeing this go up from Mumbai to Jakarta to Florida, everywhere in the world. As extreme heat waves become more common, they're placing unprecedented stress on our power infrastructure, while pushing the human body to its limits. So, of course, we look to a different friend to offer some respite. And yes, I'm talking about air conditioners, or ACs, as we would like to call them. However, when humidity climbs, room air conditioners do offer comfort, but simultaneously become energy guzzlers, costing more to run, straining already stretched grids, and frequently overcooling spaces. So the question is, how do we design and mainstream efficient ACs built for today's changing climatic conditions? It is my pleasure to invite my colleague Ankit Kalanki to help answer this question. Leading RMI's work on cooling, Ankit has been recognized as an ACHR News 40 under 40 HVAC leader. He works closely with manufacturers and partners worldwide to accelerate next-generation super-efficient cooling technologies, advance refrigerant management, and strengthen adaptation to extreme heat. Please join me in welcoming Ankit.
Thank you, Tanishka. Good morning, everyone. Thanks for joining. This is a very important topic, so I'm glad that you all are here today. Before I dive into my presentation, let me just do a temperature check here. If you can raise your hands, and if you have experienced this situation, you are in a hot and humid city, and you walk in a conference room or a hotel, or an office building, and you find it's chilly. How many of you have experienced this situation? Pretty much everyone here, right? And why have we not been able to solve this problem? Why that is the case today? How can we better design air conditioners to really address that issue? That's basically what we're going to kind of look into. So I'll start with the answer right away. This is possible, and the prize is huge. If we succeed, it could be a transformative opportunity, not just for India, but for the entire world. In the context of India specifically, we could avoid 400 gigawatts of new additional power generation capacity by 2050. If I have to give you some context here, that's almost 3 times of the total solar installed capacity today in India. So that's the kind of scale of avoided additional capacity that we're talking about. From a global standpoint as well, the International Energy Agency has a net zero pathway by 2050, and they say that if we improve energy efficiency of air conditioners by 25% by 2030, we can achieve that net zero pathway. And I say this is fully achievable because we have real world evidence that shows that energy savings even up to 50% are possible in humid climates. So all in all, this is a very, very possible task, and we really all have to work towards making sure that we can make this a reality. So I gave you a view into the future. Now let me take you back in time. Year is 1902, Brooklyn, New York. A gentleman working in a paper manufacturing plant is trying to ensure that the paper is of right quality, and he's struggling. The reason is humidity. Humidity was really affecting the paper's quality. This gentleman, I think we all know, Willis Carrier, 1902, he invents the modern day air conditioner to manage humidity. 120 years later, we have more and more air conditioners in the world today. However, the humidity aspect is really missing from the core design aspect of the air conditioners. So why has that changed? Why does humidity even matter? What's changing? How it is changing? So let's look at some of the numbers and studies that have been published on this topic. In India and the global south, heat and humidity are really rising at a very, very rapid rate. There's a term that's used, wet bulb temperatures, which is a simple, the simple version of it is the humidity. As wet bulb temperatures increases and it starts to get above 30 degrees Celsius, it really starts to impact our body's natural mechanism to cool itself. And as that reaches 35 degrees Celsius, it's basically been called as a survivability threshold for people. And if you look at this chart on the left here, you see most of the big cities in the global south are experiencing significantly higher number of hours every year where wet bulb temperatures are crossing that 30 degrees Celsius value and are starting to approach 35 degrees Celsius. Apologies for the numbers, they are very small here, but it's a significant number of hours that are impacting people's ability to really address this issue. In India, more specifically, about 3/4 of our population will be experiencing heat and humidity, will be living in areas that will have high heat and humidity risks in the next couple of decades. So this is an important problem because it impacts people. It impacts people's ability to stay comfortable, to stay productive, to stay healthy. And we therefore have to make sure that our work includes and encompasses a whole systems approach. We have to develop heat action plans so that we can better inform people well ahead of time. We can design our cities and, in a much better way so that people can adapt to that heat. But there is one trend globally that cannot go unnoticed today, which is the booming demand for air conditioners. AC demand globally has been growing significantly rapidly for the last 10 years, and it's going to significantly increase over the next 2 decades. For example, in India, the installed base of air conditioners is expected to grow by 10-fold. In Southeast Asia, it's going to become 7-fold of what it's today by 2050. So it's a huge demand for air conditioning that's going to come. And with more air conditioning, the risk is that we might be pushing our grids to the limit. We might be contributing to more planet warming emissions if we really don't start addressing the efficiency problem and the comfort problem in the right way. You can see some stats here where the peak demand, in Indian context, peak demand is going to increase by 60% by 2030. Half of that is expected to come from air conditioners alone. So that's the kind of impact that we're talking about on the power grids in this country, and I will say also in the region. I will say there is a lot of great work that's happening when you look at it from a built environment perspective. Our buildings are getting better, they're designed better. A lot of buildings are getting green certifications, compliances, they're reaching targets where they are bringing in more advanced materials so that the heat gain inside the building can be reduced, which is very important and crucial. But that really addresses the temperature cooling side of the problem. What happens is when you have air conditioning in those tighter spaces, now the air conditioner has to work harder to remove that stuffiness from the space. Primarily because if you look at the proportion of the moisture loads now compared to the loads that are required for temperature cooling, that proportion is significantly now skewed towards removing that moisture. And that's where what we all do is we pick up our AC remote and we start reducing the set point of the air conditioner, or we start dialing down the thermostat in the space, which is basically a way to compensate for proper humidity management. And we overcool our spaces, make our spaces chilly, and that ultimately wastes a lot of energy. And finally, why is this not happening? I'm sure we know what the solution could be, and the challenge is what we measure really determines what gets made. And so today, the humidity-driven overcooling energy use is not considered in the performance metrics that are really used to rate those air conditioners. Humidity conditions are not part of the testing standards that are used for designing and testing the air conditioners. And so when we have that gap of what we measure is different from, in the lab is different from what the ACs perform in the real world, there is that mismatch that occurs here. The good part is that technically we know the solutions exist. Air conditioners can be designed to manage both temperature and humidity at the same time. They don't have to significantly overcool the spaces. It can be dramatically more efficient, and it can significantly reduce the strain on the power grids. And that's what we are calling as super efficient ACs, ability to really be optimized for real world conditions and ability to drive the performance in line with the real world conditions. And we are not just making this up. We have data that we have measured and collected through a 9-month-long field testing in Palava city in India. If you look at this chart here, the first 2 bars are basically showing you how much energy gets used by typical air conditioners when they're operating in a hot, humid city. The blue bar here, if you look at it, is the energy that gets used just to manage the temperature or achieve a temperature set point of 27 degrees Celsius. When we add in the comfort layer, which is in this context is only referring to the relative humidity factor, now the AC has to work harder. Now the set point has to be reduced so that the RH can be met in the space. And that's where that orange bar comes in. That additional energy which goes towards overcooling is not getting accounted for in any of the metrics and the standards today. And that energy is almost about 30% of how much energy air conditioners use in the real world scenario. The green bar here shows what potential we have from the super efficient prototypes that we have tested. 60% energy savings can be achieved by designing ACs better. And it's not just humidity control. Humidity control is a big part of the 60%, but obviously there are better components, compressor, heat exchangers, but humidity control, real-world optimization is a big driver of that 60% energy consumption, and we really should be working towards making that a reality. So there has been a lot of work that's been happening over the past few years. RMI with partners, CEPT University, with partnerships with manufacturers, with the buyers. We have been really at it, using these evidence, building the foundations that will ultimately make these super efficient ACs a market reality. How can we bring these out from a proof of concept stage to a commercialized version is something that we are really focused on. And as part of that, we have been focused on building evidence that can support standards change, engaging with manufacturers and buyers to kind of keep the ecosystem moving in the right direction, and ultimately exploring the different market mechanisms, financing mechanisms to help, once those proof of concepts are brought out, how can we help them scale? And we are not alone in this journey now. It's been about 3 years that we have been at it, and now we are starting to see a global shift, which is underway, which is starting to recognize and realize that we have to design air conditioners for real-world use. So the International Standards Organization is actually in the process of coming up with a standard that will recognize and require ACs to have a certain amount of dehumidification in the future. At the same time, there are more research groups that are really keen on understanding how humidity can be integrated into test protocols around the world. So there is momentum in that direction as well. And a group from the United Nations, which is U4E, which develops a lot of energy efficiency benchmarks for various countries around the world. They set the minimum energy performance standards, MEPS. They help governments kind of implement that. They have taken our super efficient AC performance targets and incorporated that into their upcoming model regulation guidelines as a voluntary benchmark for what an ambitious target should look like. And if there are countries that want to take that next step, they have a target in front of them. So there are 2 key stakeholders now, which are obviously critical. Policy aside, from a market standpoint, manufacturers are absolutely critical to this entire conversation. And this is a great time for manufacturers to engage and really stay ahead of the curve. Because by engaging now, manufacturers can start conceiving products, validating them, testing them, start thinking about what kind of investments will be needed from a testing infrastructure standpoint, skill development standpoint. I think those kind of conversations need to happen now so that we can really pave that pathway to commercialization. Manufacturers can play a very key role in ensuring that the standard ecosystem understand understands how to adapt those changes to the local context. What will it take for an ISO standard to be adapted to Indian context? And I think that's where manufacturers can also play a very critical role. And I'm really glad that we have multiple manufacturers that have taken that leap in working with us to start developing those proof of concepts so that we can show what's possible. The other side of the equation, the demand side, the buyer side, again, they are extremely critical in this overall conversation. Pilots create those, take those proof of concepts to actually show what's possible to the real world. It generates confidence among the buyer community. It generates confidence to the manufacturers that there is offtake potential down the road. And it also helps policymakers and regulators, because now they see that both the demand side and the supply side are working towards a common goal, and they can actually work towards making more systemic shifts, more policy changes that are required to make this happen. And again, in this context, we have been grateful to have a partner like Lodha, who has been very helpful in allowing us to test those prototypes, those technologies, to show the world what's possible, what kind of engagement we can drive with those kind of efforts has really kind of been seen through this engagement. So, final couple of slides here. Why India? Why can India really lead this transition, this market transformation? How this country is uniquely positioned to do it? There are three key areas which I think are really setting this up really well. Policy foundations. India has a strong foundation in the India Cooling Action Plan. And there is intent from the policymakers, from the regulators, to keep ratcheting up the energy efficiency. So that willingness is there, that exists today. Manufacturing ecosystem, we are seeing a lot of investments are being made, to bring supply chains here, set up more factories, set up more R&D infrastructure. So manufacturers are starting to make more investment towards just growing this overall ecosystem and more manufacturing in India. And most importantly, I'll say this market offers the huge demand potential. It's a huge market, not just this country, but the global South. Like I showed, Southeast Asia, beyond South America, all of these countries have similar tropical conditions that offer a big market opportunity for the industry overall. So I really like to think this as like India has an opportunity to make in India, not just for India, but make in India for the global South and for the world, actually. This is the kind of opportunity we are talking about. This cannot be done by one single stakeholder. We need everyone together. We need a lot of people, a lot of market actors to really come together, take action. That's the ultimate goal. We have to take actions. There is a very popular stat from IEA which says 10 air conditioners are sold every second in the world. So by the time we end this session, 36,000 air conditioners would have been sold somewhere globally. So we cannot let this kind of inefficiency get locked into our systems, because that's the kind of impact that we're talking about. So we all have to come together. Standard bodies and policymakers have to show the intent to measure the right things. Buyers can really start demanding for products that not just look at a metric, but look at comfort and efficiency as a combo. Manufacturers can act now, like I mentioned, to start conceiving those products, to start thinking about what the roadmap should look like from an investment standpoint and from a standards and regulation standpoint. And then ultimately, the larger community of academia, civil society, financiers, how can we all come together and act to move this work and make super efficient ACs, and more specifically, real world aligned ACs a market reality. Thank you. With that, I'll hand it over to Tanishka.
Thank you for that insightful overview, Ankit. It's actually fascinating to note that ACs in peak seasons require 30% additional energy to manage humidity. And clearly, as the demand for ACs booms, we have the opportunity here in India to capitalize on that and really bring solutions that matter. And we have just the right people in this room today to take this conversation forward. It is my pleasure to usher you into this next segment and introduce our moderator and esteemed panelists for the day. First up, we're fortunate to have Dr. Yash Shukla as our moderator today. Dr. Shukla Dr. Shukla is the principal researcher and center head at CEPT University's Center for Advanced Research in Building Science and Energy. He brings over 2 decades of experience in high-performance buildings research and plays an active role in national and international technical forums. Welcome, Dr. Shukla. Also joining us today, we have Mr. On Abdullah, Vice President at Lodha. He has been developing the company's sustainability and ESG strategy since 2011 and helped establish the Lodha Net Zero Urban Accelerator for Lodha Foundation in partnership with RMI. Welcome, Mr. Abdullah. Next, joining us today is Mr. Mukundan Menon. Mr. Menon is the Managing Director of Voltas Limited and the President of the Refrigeration and Air Conditioning Manufacturers Association. With over 3 decades of leadership experience across the HVAC industry, he is known for his strategic understanding of the opportunity that awaits India in this domain. He is actively driving industry and policy progress. Thank you for joining us today, sir. Next, please join me in welcoming Mr. Sanjay Sudhakaran. Mr. Sudhakaran is the Managing Director of Bosch Home Comfort India Limited. He has over 25 years of global experience across major MNCs and has led complex businesses through transformation, innovation, and operational excellence across the HVAC and refrigeration sectors. Welcome, Mr. Sudhakaran. And finally, it is my pleasure to introduce Mr. Bishal Thapa. Mr. Thapa is the Chief Strategy and Impacts Officer at CLASP. He brings over 20 years of global experience in energy, climate, and sustainability, with a focus on accelerating efficient appliance markets worldwide. Welcome, Mr. Thapa. And with that, I'll hand it over to Dr. Shukla to take us ahead with the panel discussion.
Thank you, Anishka, for the kind introduction. Thank you to the panelists for taking the time today for the discussions. Thank you for all the audience for joining this session. I have a call with Ankit for a wonderful presentation, but he took away all my question points, and all the answers have been given to the panelists what needs to be done. So now I'm going to have to refine my questions to make it a bit more uncomfortable for everyone, because as moderator, my role is to get things that we really don't know that Ankit talked about and get out from the panelists. So I'll start with you, Mr. Menon, as a leader of the industry association as well as representing Voltas. I'd like to ask you that India has a very unique position right now. And it has a contextually, humidity is a very important element. We are sitting in the city of Mumbai, so it can't be a better place to ask this question. So how can India take the leadership, as Ankit mentioned in his presentation, to bring this super efficient ACs into the market? Now, I want to just qualify what super efficient ACs in this context mean, because it's a newer term from some of the people here. What we mean by super efficient ACs are not something that performs exceptionally well in the standards rating system, but which works in the real world very well, provides performance in the real world, and manage comfort, not just temperature. So temperature and humidity in the larger context of this presentation. So that's how we are defining super efficient AC for this session. So how can we bring that up? And my question to you is that, why has that not been done till now? Why do we need to still talk about it? Why didn't industry bring it that ace in the market?
So good morning, everyone. Very happy to be here, and Ankit, thanks for the lovely presentation. And a lot of familiar faces in this room. I think many of us have worked together in different organizations. I think at least 20% of the room, I think, faces are familiar, and it's very happy to see all of you here. So essentially, the fact of the matter is India is currently roughly, in terms of room air conditioners, roughly 15 million air conditioners get sold annually, growing at a CAGR of roughly 15%, which means in 5 years it will double. So it's 30 million in 5 years. And then it probably might taper down. This is driven by the fact that the current level of penetration in India is very low. It's less than 10%. Now, most of the developing countries itself have penetration level upwards of 40%, 50%, 60%. So the fact of the matter is that the demand for air conditioners very, very strong over the next decade or so. So that's while it's an opportunity for all the brands and the air conditioning manufacturers, it's also a serious call for action in terms of what impact it has on the climate. Because if this is done in a completely controlled manner, things can really go, as you rightly said, between now and 2030, almost half of the requirement of the peak load happens because of the air conditioner growth. And I probably feel it will be a little more also. So that's the context. Now, before we jump into the issue about humidity as the key driver for this containment of this energy requirement, I think there are some other fundamentals which are also probably needs to be looked at. For example, today all air conditioners are temperature-based energy standards, and everything is based on the temperature thing. We also have a system where air conditioners, a 1.5 ton air conditioner is supposed to deliver around 5,200 odd watts of cooling. Now there are manufacturers who manufacture inverter air conditioners at an output of only 4,400 watts, which is equivalent to a 1.3, less than 1.3 tons. Now, an inverter, what it has a function is it can raise the temperature, raise the frequency, and it can run at a higher speed, and it can deliver you higher capacity when the need arises. Now, when it does that, it consumes a huge amount of power completely. If a 5-star air conditioner is operating at suboptimal frequencies, it becomes less than a 1-star. Can you imagine a 5-star becomes a 1-star when it is operating at suboptimal frequencies? So there are some fundamentals there which need to be corrected. A 1.5 ton air conditioner should have a threshold that a product cannot be manufactured or sold when it is being rated at normal speeds of 50 hertz at less than 1.3 ton or 1.2 ton, and then it is made to run at suboptimal frequencies, suboptimal speeds. What happens is the energy consumption goes through the roof, in addition to the fact that the machine life reduces, obviously, because you're... So there are some basic fundamentals which need to be fixed first. Humidity point is a very valid point. See, India is a country with 5 climate zones. The hot and humid is roughly around 40%. There are also the arid and dry and arid sort of climate zones which are also... So roughly, to my mind, around 40% is the humid and hot and humid temperatures. The rest of it is a composite temperature. Some of them are like hot and arid temperatures. So in places where this humidity is a major thing, which is essentially the coastal belt, that is the area where this entire thing plays out. Now, why is that? Your question, Yash, is why did the industry not think about this earlier? See, India is a country where the majority of the middle class is buying air conditioners for the first time. Affordability is a very important criteria. They need comfort, and the manufacturers have to manufacture products which are at affordable prices. Any layer of additional layer which is added in this thing. So the standards have always been like between 2010 to 2026. I think we have had 4 or 5 energy label changes. The power consumption of what was consumed in 2010 to today, I think we are less than half of the energies. So has India done enough in terms of having more energy efficient systems? And the answer is yes. And the government and the Bureau of Energy Efficiency has played a very significant role. Is there room for doing something more? Absolutely right. Because currently the system I was mentioning, the way I was mentioning that there is a delta between what is rated on the machine and what is the real world consumption.
Absolutely.
That comes from many things like what I mentioned about capacity, the frequency that it is running, in addition to the fact that the humidity. So there are multiple things that the industry can do, and I think you have captured it well. The standards, I think, needs to be changed in terms of testing of this, including humidity as a parameter. Second is the energy efficiency norms will have to get synchronized with this new testing thing. Manufacturers have to start building machines with those humidity sensors, which will take up cost for sure. They'll have to develop algorithms which will work around and pick up that data and then adjust the compressor working. So this entire thing needs a fair amount of coordination between these 5-6 stakeholders, which you rightly mentioned, Ankit. So there's a major work to be done, and whether the industry is ready for it, I think the industry is more than ready for it, because India's growing market, 30 million units in 5 years, India becoming very strong manufacturing R&D capability center for the entire world as an alternative to our neighboring country. I think we have a great opportunity to start working in all these areas, and as you rightly said, become a champion for this global south in terms of manufacturing products which are real life energy savers, not on paper, you know. So, yeah.
Excellent. Thank you, Mr. Menon. So I'll put that to on now. So on being part of the Lodha Foundation, I would like to reach out saying that what motivated you to allow these super efficient ACs testing in your city, Palava city, and what would enable to have more people achieve that or require that to do in their facilities? What are the factors? So Mr. Menon talked about the affordability. Is it only the initial affordability? Are there other factors that you are considering? What are the elements that you actually consider when you select and think about these newer generation super efficient air conditioning systems?
So thanks, Yash, and Ankit for having me here. We are not looking at thermal comfort or an air conditioner in a silo. Our focus, and I'm wearing two hats. I'm wearing the hat of Lodha developers, and I'm also wearing that of Lodha Foundation. And at Lodha Foundation, our focus is basically on sustainable urbanization. There are various focus areas on which we are working, and all of them are oriented to contribute towards India's growth. The amount of urbanization that is going to happen in India is unprecedented. We see that close to 100 million people will become home ownership capable. 500 million people will start living in cities in next 10-15 years. And with that number, actually your number looks smaller. I think it will be bigger than what the amount of ACs that you are expecting. So the point is that while on one hand we see that cities will become these growth engines for the country, we might end up making our cities which are a drag on the Indian economy. Now, both in terms of the energy that we use, and we are not an energy secure country anyways, the amount of resources that we need to build all of this, at the same time, not cleaning up our energy ecosystem and then ending up in a more serious and severe climate crisis is a much bigger issue to solve. And we see that everything is getting aggregated within this within this realm of urbanization, and so sustainable urbanization is the goal. Within sustainable urbanization, one of the key factors on energy is basically cooling. And as Ankit was saying, that ultimately it will go and start squeezing the grids is what is the main concern. We need solutions. We are not air conditioning experts. We can plan a city better, and it can be not as impacted by urban heat. But then obviously the equipment has to go in, and that the best in class equipment has to go in. We need the market to innovate for that equipment. Why we are ready to allow our facilities to be used for any kind of testing is basically just to play that small role of an enabler, so that the overall case can be built better. And because we also have this unique opportunity in the name of the city that we have developed, I think it is our, we must share it with everybody so that it can be used to try out not only air conditioning but any other type of solution as well, which can help India urbanize better and safely grow instead of losing the opportunity of growth by not considering these factors.
Okay, so what I take there on is actually you have to put these new technologies in the context of other elements that needs to be brought into the cities and how it integrates with that. But I still want to, ask that question what motivated you and how can we motivate others to take up the adoption of these super efficient, real world performing air conditioning system? Do you have any suggestions for everyone to start?
See, a lot of people come to us with a lot of solutions and they say that this is the magic bullet. It will reduce your energy by so much and it will increase the reflectivity by so much. And we also need to develop confidence in a product which we eventually wish to scale. So if I go back a few years, RMI told us that you just shift from 3-star ACs to 5-star ACs across portfolio, whether be it affordable housing or any housing, because the overall impact it brings. We took that call and we moved ahead. Now comes the question that where will we go from here? We will go from here to a super efficient AC. Now, should we be not engaged and one day you come to us and tell us that this is the AC you should buy? Versus if we are fully invested and integrated in the development of this air conditioner, we will be the first people to actually make this commitment and buy and leverage our bulk procurement capacity. We feel that if we develop this confidence and we bring our volumes to the table, we can sort of also help create some sort of buyers coalition where volume can be created and this enablement can happen. Without being into the experiment, we may not have that confidence. So that is why we are doing it.
So that's a great point, that having a confidence of the unit to be able to perform, it plays a major role in your selection of the equipment. So I'll pivot that to Mr. Sanjay. I have a couple of questions for you. I'll club them together. Building on what On mentioned, is that do you think that we can give this confidence? Are there innovations required? Are the technologies matured for this real world performing humidity optimized systems? Are there technology available? And if not, what do we need to do? And then how do we help scale that up? So I'm going to club that questions and request Mr. Sanjay for your inputs on that.
So from what I understand, your question is from the super efficient air conditioner that we just saw in Kit's presentation also, what it meant was that comfort was always seen in terms of temperatures, though we studied in textbooks that it's a matter of humidity and air velocity as well, but we never really took those principles because humidity control became a byproduct of the temperature control. And frankly, comfort is something that is intangible, differs from person to person, so you just cannot have a standard around comfort. Whereas other aspects like temperature, power consumption, etc. are tangible, can be measured. So the industry as a whole and the regulators as a whole have pursued these two parameters in trying to define what the efficiency was. Now, when it comes to humidity, we saw that example from 1902, right? It started off with humidity control. So technologies definitely exist to manage humidity and manage temperature independently and together as well. But the problem, and we have seen that in specialized industrial applications where you have very precise humidity control, right? In say pharmaceuticals, high-end pharmaceutical factories, etc. Very high-end precision humidity control and temperature control both combined together. So technology exists. Now, how do you adapt this technology? It's very simple, like your mobile phone, right? The moment technology adapted and miniaturization came into play, your mobile could act as a camera, right? Unless you had two bulky devices, now you have one device, which is very compact and serves two purposes and many other purposes to that matter. So probably the air conditioners of the future can be designed to do that. So it's eminently possible. The principles are known by us. What needs to be done is innovation in the area of miniaturization as well as sophisticated controls and electronics, which can help achieve these parameters within a realistic sphere of affordability, which Mr. Menon was talking about, right? India is a growing country. We cannot sacrifice growth for sustainability or sustainability to growth. It has to coexist together.
That's an excellent, it's a music to my ears when I hear that the technology exists. It required some elements to work on it, but there is a huge potential. I still want to prod on that follow-up question saying, how do we scale it up? Do you think there is a potential to scale it up? Are there market barriers that we need to work on? Some of that was covered by Ankit, but I'd like to hear your perspective on that. What would enable you and Mr. Menon to build these ACs and then scale it up to a level that we get a country level benefits that we saw in the presentation?
Sure. So I would say that having worked across 2-3 different industries, I feel that the air conditioning industry is the most regulated industry today. And given the size and potential for growth, it is also the most complex in terms of supply chain. So there are a number of interests or the number of barriers, tariff barriers, non-tariff barriers, import regulations, protectionism, along with energy consumption norms, which are all bearing on the industry and preventing it from innovating. So the industry is forever catching up. There are huge investments in R&D. Everyone has a fantastic R&D center, testing labs, etc. More coming up. We are also doing the same. But all these resources are used to catch up. And that is not only true for India, it's true globally. Everyone's just catching up with more and more stricter norms. From what I understand, Japan is trying to now roll back some of these because it's starting to hit a point where inflation will outweigh growth and it might stifle the industry. So I think we need to be clear along with the regulators and as a country as a whole, which direction do we need to go? Should we innovate or should we just play catch up? Because right now, given the affordability of the whole situation, everyone's just playing catching up.
Thank you. That's a wonderful point and very pertinently brought up. I'll now at that point move to Bishal, who I have strategically kept him the last because I want him to hear all the inputs from the other people. And Bishal has been involved in many policy making support role, providing the evidences and knowledge for that. So Bishal, coming back to you here, asking that, listening to what you have, what do you think are the policy aspect that needs to be worked in enabling the development and the acceptance, adoption of these super efficient ACs? And what do you think about the need of these in terms of the benefit to the country from the policy perspective and the scale perspective?
Thank you, Yash. Just working? Yeah. Thanks, Yash. Great question. Great to be on the panel. Good morning, ladies and gentlemen. Ankit, great presentation. I guess he said you have to be last on the panel, listen to everything else, but now that everybody's done speaking, everything has been said, all the points have been made, all the data has been shared. So I was trying to think what story I can tell you. So I have a story, a different story. And it's from sports. We're in the middle of the T20 World Cup, right? But cricket is not the sport I want to pick up on. It's actually the less talked about cousin of cricket, which is hockey. How many hockey players do you see advertising ACs? Not many. How many cricketers do you see advertising ACs and other products? Quite a bit. But here's my story on hockey and how it connects to AC. So in 1928, India went to the Olympics for the first time. It played 5 matches in hockey. It conceded 0 goals, and it won the gold medal. Right? After that, it won many gold medals in the Olympics in hockey. In fact, Dhyan Chand was so good that when he went to play in Germany, they said they took away his stick because they thought he had some like Indian magic in his stick because all the ball would keep sticking to his stick. So he was like Messi with the stick, even better than Messi with the stick. But as you know now, like where are we in hockey? If we make it to the World Cup, we're like, damn, you know, like that's pretty good. And we make it to the quarterfinals, we're like, whoa, we're really doing good. So 100 years from 1928 when we won the first medal and basically shook up the World Cup in hockey, and like, where are we today? So what changed? Somewhere in the 70s, in fact in 1978 to be precise, they changed the turf for hockey. It went from a natural field to an astroturf. And that changed the game of hockey. It moved from a game of finesse to a game of power. It became all about speed, and then more change came about in hockey, right? Like the way you lift your stick changed, the way you run changed, the way you passed changed. All sorts of rule changes came. And it was pretty tough after that. The power, the center of gravity in hockey shifted from South Asia towards Europe, and it changed. So when Mr. Sanjay says, you know, are we going to innovate a catch-up? If you want to fix the problem in AC, it's like changing the turf. You got to innovate. Because if we're going to try to win the World Cup on AstroTurf, it'll take you 100 years, maybe, and you get to the quarterfinals or the semifinals. Pretty tough. So, humidity is like changing the turf. If you want to catch up, we got to innovate. We got to change the turf. And humidity is that dimension that brings the turf in. That's the point. We have two challenges here in India and actually many parts of the world. Our access is very low. Only about 10% of the population actually owns an AC. So we got to find a way to make it cheap, affordable, and really accelerate it. And we saw the numbers. If everybody owns an AC, it's a huge impact. So we got to figure out a way to make it super efficient as well. And when you bring both of those dimensions in, I think humidity is like the innovation. It's like changing the turf that suddenly allows the game to be different. It's what reduces the costs and makes it accessible. It's what brings in the efficiency. And so when we do that, I think that's the innovation we need that allows us not just to catch up, but to be way ahead. And it addresses the need that we have. And it fits our context, it fits our weather, it fits our environment. It's the turf that we know how to play in. And in order to enable that, I think there's lots of different types of policies that have to come into play. Policies that recognize this change, that allow it to be tested, that allow it to be, to really come into the market. And there is a recent innovation, actually, that is very much an example of this. And I just want to mention it. It's LEDs. Like if you look back, even just over 10 years ago, when CFLs was still the big thing, right? When LEDs came in, the acceleration that we made in terms of shifting to LED as lighting suddenly changed the game for India. It not only made electricity access a lot faster, because LEDs really drove that access, but second, all of a sudden India is one of the largest producers of LED. And so from being an importer of lighting products to being one of the biggest manufacturers and exporters of LED products, that changed because we changed the technology. The service it provides is still the same. It's lighting. But its ability to give access, to make it affordable, and to drive economic growth through production and manufacturing was just unprecedented. So I think this is the inflection point we're in. We can continue playing in the AstroTurf, or we can switch and go back to playing in a field that suits our context, that suits our expertise, and that suits our ability and meets our needs. And I think this is the choice we have to make. A lot of things have to obviously come into play for that, but I think this is the choice that we have.
Thank you, Prashant. So there's a good reason why we really kept you last and you talked about storage. So what a great point to say that this could be the LED movement in the air conditioning industry and actually changing the turf to cater to the both challenge of catch-up and the regulation. Wonderful. I can talk another hour with this panel, but I have only now 5-7 minutes left. So what I'm going to request is in the next 5 minutes, each of the panelists, I'd request them to talk 1 minute on one change they would like to happen over the next 2 years in the industry to enable real world performing super efficient ACs that benefits the country. So request you to only focus on one point that you think is the most critical and keep it for 1 minute so that we can close in time. I wish the panel discussion. Starting with you on and then go to Mr. Menon, Sanjay ji and Vishal. I'll keep you the last because I like the stories that I have to challenge you to get these certain elements in.
In this one, I could have been the last so that I would have heard what others are saying and what to say. But so what I would like to change in the next couple of years is, one is that I have seen you and Ankit being a lot enthusiastic about this, and we have been fully supporting. I would like to see the manufacturing ecosystem to become as enthusiastic. And that might happen if the policy accepts the fact that humidity has to come in. I do not know who all has to be moved to make that happen. We are willing to allow you to do as many tests and experiments within our cities. We are willing to do that. But that is one thing that is key, is that the manufacturers in India become as excited about the technology as as you are. The manufacturer.
Yeah, so I think essentially it's all around the real. When somebody buys an air conditioner and then puts it at his residence, it has got a label, it has got it's got a rating, it's got a capacity, it's got a cool energy efficiency, and so on and so forth. The final proof of the pudding is when he uses it over a period of time, what is the energy that it really draws during a real life situation. Now this has multiple facets again, as I said, there are few other factors, humidity is one of them. So if the entire testing process, the BIS regulations and the energy label as Bureau of Energy Efficiency's standards revolve around the real energy consumption spread over a longer period of time rather than just testing it at 35 degrees centigrade with a wet bulb of 19 or whatever it is, and then rating it as a star, a 3-star or a 5-star. I think that's an idealistic situation. Indian temperatures and humidities are completely different. You know, they are not this ideal 35 dry bulb and wet bulb temperatures. So I think this entire thing, if we can get the standards corrected to really reflect the real life, the real temperatures and humidity of India, the way I think Vishal was mentioning about the Indian turf, you know, the Indian thing. I think that's one very important thing which we have to do. And as a representative of the association, I think I will take on the responsibility to work with you and then sort of get to a situation where we do not do this just idealistic ratings and then live in a completely false world compared to what the real consumption is. And the delta between these two are significantly high. It is not a marginal delta. The real consumption versus what is rated is completely different. Even there are things when you rate a product at 35 degrees centigrade, when it goes to a temperature of 44, the duration of the system makes the system run at completely suboptimal speeds, and the real consumption can be completely off from what the rating is. So I think working on the standards with the Bureau of Energy Efficiency along with the BIS is something that I think we as a group can do. And I take on that responsibility. Yeah.
So my take is that as an industry, as academia, as regulation and as government, to try and build a more comprehensive 10-year roadmap rather than think of incremental gain in efficiencies and follow the rest of the world. I think if we can create something of that sort, tough to do so, but I think that would really spur innovation.
Yeah, I think my call to action would be to really galvanize the industry and buyers And I think all of the pieces are there. I know we need many regulations, et cetera, to sort of come into play. But I would say that I think manufacturers and buyers should make voluntary commitment to produce at least a certain amount of humidity, systems, humidity-based control systems within the ACs, and buyers should commit to it. And I think once that happens, with that commitment, a voluntary commitment, I think policy will just fall into place. So I think here's a real opportunity for leadership that I think in this case, policy will lag that action. And I think there's a real opportunity for industry and buyers to come together and just announce it and build the turf.
And so this is great to hear. We have clear pathway and action suggested by everyone. Taking ownership by Rama, President Singh will take ownership in having the industry leadership and the market demands and developer representative talking that we are ready to experiment. I mean, we can't hear anything more than that from this panelist. So I thank you everyone for taking the time, and it's been an honor to talk with some of the stalwarts. I want to end with two points very quickly from my side. We are talking about hot and humid conditions. We have at CEPT University with our partners have built a heat experience chamber in the exhibition. So I would request all of you have time to go through and experience 5 minutes of 40-degree temperature in a emulator and understand how it affects the physiology. So I would request you, my call of action would be to, if you can go and spend 5 minutes of your time and experience that to understand how physiology changes. We have a right example in the exhibition in Jasmine Hall. And the last point I want to say is that I was the only one not wearing the jacket here in the panelist. And that's not for disrespectful purpose, but as a university, we believe that we need to be more contextual. We have been working on adaptive thermal comfort. So I encourage that we actually look at also the clothing aspect and the behavioral aspect. And so that's the reason that I wanted to kind of make the last point. Thank you.
Thank you, Dr. Shukla and everyone on the panel. We're truly grateful to have heard from such a distinguished group of leaders today. And it's amazing to see their shared commitment to advancing super efficient ACs in India and across the global south. And as Mr. Thapa said, we eagerly await the future where super efficient ACs become the next LEDs. With that, I would like to invite Akshama Ghate, Managing Director of RMI's India program, to deliver the closing remarks. Akshama leads research, analysis, and partner engagement at RMI to transform India's energy landscape. Over to you, Akshama.
Thanks, Tanishka. So Ankit did insist that I do give some remarks. So I don't think I'm adding any value except for thanking and recognizing the timeliness of this conversation, especially I think as we head into the heat and humid seasons that are kind of, staring at us. A lot of you who probably are in Delhi or have visited Delhi would have seen how tough the winter, how cold it was, and how suddenly, just in a matter of days, we've shifted to the heat. And I think the humid season is not far away, also sitting in Mumbai. So just wanted to thank our moderator, Dr. Yash Shukla, also to our panelists on Abdullah, Mukundan Menon, Sanjay Sudhakaran, and Bishal Thapa, and also for everybody in this room for joining us. It's an important conversation. As I said, not just a matter of few weeks, not months, that we will be in a season where, this conversation that we are kind of talking is more of an experience. And, Yash was inviting to the heat simulation that you've done. I would invite you to Delhi or just be, So I think it is something that, it's not easy to survive. Even I've had, instances that I've parked my car. I know the conversation is humidity, and Delhi is relatively better than some parts of India. But I remember parking my car in the open and coming out, and my car temperature is showing as something like a 52, 53 degrees. So that's the reality we are living in. And I think it's just getting worse for us. Very critical for us to, start paying some serious attention to it. We've heard from the panelists what needs to happen. We can kind of keep repeating ourselves as RMI that it's very, very important, because we start acting now, because we are still to see a lot of these sales happen, a lot of these, homes to be constructed. So very important that we kind of act now and build it right, whether it is ACs or homes, build them right the first time before, we just kind of lock ourselves into inefficiencies in the future that, Ankit very insightfully presented to all of us. So just with that, thank you so much. Thanks for being here. We hope that as RMI team, we can be in touch with many of you in terms of your feedback, reflections on what you thought of this work and how we can also collaborate with you all. So thanks all.
Thank you, Akshima. Just as we close, we would like to request you and Ankit to join the panel for another photo.